Ever wondered what's really going on when things burn, rust, or fizz? These are all examples of chemical reactions happening around us every single day. But what actually happens to the atoms during a chemical reaction? Let's break it down step by step. Everything around us is made of tiny particles called atoms. Atoms join together in groups called molecules, held by chemical bonds. In a chemical reaction, these bonds are broken apart. Then the atoms rearrange themselves into new bonds. This creates brand new substances with completely different properties. The starting substances in a reaction are called reactants. The new substances made are called products. Think of it like rearranging Lego bricks into a new shape. You still have the same bricks, just connected in a different way. That's exactly what happens with atoms during a chemical reaction. No atoms are ever created or destroyed during a reaction. This important rule is called the law of conservation of mass. The same number of atoms you start with, you end with. They're just arranged into different combinations than before. Let's look at an example. Methane gas burning in oxygen. Methane and oxygen react to form carbon dioxide and water. The carbon, hydrogen, and oxygen atoms don't just disappear. They simply swap partners to form brand new molecules. Chemical reactions also involve important changes in energy. Breaking bonds needs energy, while making new bonds releases energy. If more energy is released than used, we call it exothermic. Exothermic reactions release energy, often as heat, light, or sound. If more energy is needed than released, we call it endothermic. Endothermic reactions take in energy from their surroundings, often cooling them. So, how do we actually know a chemical reaction has happened? Look for clues like a color change, gas bubbles, or a new smell. Temperature change or a solid forming, called a precipitate, are clues too. All of these signs show that new products have been made. So a chemical reaction is really just atoms rearranging, with energy changing too. Next time, we'll explore the difference between chemical and physical changes.